Okay, in this lesson we're going to look at vertical translations of the trigonometric function. Okay, after this we'll start looking at combining all these different transformations on the function. So a vertical translation is just a shift upwards or downwards. It's just moving upwards or downwards. And what will happen is if we add a constant to the function, that's going to cause some kind of vertical translation. So again, this is best explained looking at it in action. So I've got a slider here, and I've defined my function as follows, going to be whatever the value on the slider is plus the original sign of the function. So at the moment the value on the slider is 0, so this is just the function f of x equals sine of x, which is the parent function for all sine functions. It's the simplest version of it. I've put in my midline here. It's the line y equals 0. It's that red line in the middle. And I just want to look at what happens as I slide this value for a. So if I move up here, what's happening? You can see the function value here changing as I move. At the moment a is 0.6, so I have 0.6 plus sine of the function. And I'm hoping you can see there fairly straightforward. The actual shape of the function is not changing at all. It's just been moved straight up when I'm increasing in the positive sense, straight down when I'm going down through the negatives further away from 0. Okay. So, and I want you also to look at the equation of the midline as I do this. So we'll go back to the original function. There's my parent function, f of x equals sine of x. And I'm just going to move that. In fact, I'm going to just change the increments to make this a little bit easier to look at. I'm going to change them to, say, 1. So if I move up to 1 here, we just have 1 plus sine of x is now my function. Notice the midline now is y equals 1. So every point on that line has a y coordinate of 1, so that line has the equation y equals 1. If I move up to 2 in the positive way, the function hasn't changed shape at all, so period is still the same. The amplitude is still the same. The height above the midline isn't changing. The range is changing though, and the midline is changing. You can see that. I move up to 3, the midline's gone up to y equals 3, move up to 4, and you can see the midline there is y equals 4. Going down into the negatives, when a is negative 1, we've got a midline here at y equals negative 1. Notice the function, the main kind of things are not changing. There's 2 pi, so the period is still 2 pi. The amplitude, the height of the function is still 1 unit above the midline, but the range is changing because from here now, the range is going from negative 2 up to 0. So adding that constant outside to the function is causing a vertical shift, a vertical translation. Let me put on the animation, and you can see that. Actually, I'm going to stop that and change the increments so you see that a little bit better. And you'll see that as a is changing, this thing is just sliding up and down. The period is not changing. The basic shape of the function is not changing at all. What is changing? Well, what quantities are changing? Period is not changing. Range is changing because the lowest and highest points are changing. The amplitude, however, is not changing because the highest point is still the same distance above the midline. Okay, and the midline is changing. Okay, so let me generalize that. And again, these are things you just have to learn by heart and remember, but understand them by practicing. Practice with GeoGebra. If I take the function f of x equals some constant plus the sine function, what happens here? Well, what doesn't change? The period does not change. It is still 2 pi. It's still the same as the period of that function. The amplitude doesn't change. It's still the same as the amplitude of the sine function, because all this quantity is doing is it's moving the function up and down. What does change are the midline, and the midline is just going to be y equals whatever this value I've added on here, a, is. What also changes is the range. It's moving up and down. Remember, the parent function had a range from -1 to 1. All we're doing by adding an a in here is just adding a in here. Okay, so the range -1 plus a to 1 plus a. So for example, if I look at, let me make up a function here. Suppose I took the function f of x equals -3 plus sine of x, period 2 pi, amplitude 1, because they're both the same as the period of and amplitude of the sine function. But the midline now is going to be, the midline is going to have equation y equals -3, whatever that quantity I've added in there is. And the range, well, the range is now going to go from -1 added to -3 up to +1 added to -3. So the range for that function will be -1 subtract 3, -4, comma 1 minus 3, -2. Notice there's still a distance of 2 units between those two things, which means the amplitude is still 1. Okay, so -3 plus sine x, midline y equals 3, range equals -4 to -2, period 2 pi, amplitude 1. Again, check that out. Let me actually just freeze that at the place where a is equal to -3, and you'll see that nice and clearly. So there's my function, -3 plus sine of x. You can see the midline there, y equals -3. That red line, every point on the red line has a y coordinate of -3. You can see the range here going from -4 up to -2. Period still starts here and still finishes at 2 pi. There we are. 2 pi. So, get used to that, learn all those things off. In our next class, we'll look at combining all those different translations. But get familiar with them now.